Right, welcome back. Okay, so we're doing, let's see, we're doing number 54 on page 667 of chapter 11, section 2 of Thomas's Calculus 14th edition. And you know what, let me just label my output here a little bit. I forgot to do that. There you go. All right, so the first part is to enter the parametrically defined trajectory that we're given. X of t is, and this is a lot like 52 if you take a look at my video for 52, with the same idea, but it's a different path. So e to the t times cosine of t. Okay, and let's just show that, make sure my input is correct. When you least expect it, that's where your errors are going to come from if you don't check as you go. So this is Pythonic in sagecell.sagemath.org, a computer operating system that's free to use in the cloud on the Google Compute platform. Here's y of t is e to the t times sine of t using free Linux open source software, Floss. Have you flossed today? Do you use Floss? Have you used Floss today? Okay. Anyhow. So here's the trajectory. And so if you saw my other video, what this is we're trying to get the arc length along this path. And we're going to estimate it with 2, then 4, then 8 equally of line segments of equal length, and see how that sort of converges to the actual arc length formula. And I like to separate my output a little bit with a blank line and a blank line in my input. Or I click evaluate, and all you got is your input. A little white space. Good, perfect. Okay, so now let's generate 2 lines. And by the way, this goes from 0 to pi. All right, so let's generate 2 lines. We're going to do this sort of like a Riemann sum. We're going to do a delta t, b minus a over n. So what's a? They want you to start at x equals 0. What's b? They want you to stop at x equals pi. Pi is predefined in here. What's n? Well, we're going to do 2 line segments. So what's delta t? Not delta x today. These are functions in t or maybe possibly time, right? Quantity b minus a all over n. Well, in this case, clearly that's going to be pi over 2. And let's show all of that stuff. So here we go. Okay, so a equals a. Now let's see here. Let's see if I can copy this. Come on. What just happened here? There we go. I want to copy this. I'm on my tablet. So it's a little bit different from a Chromebook, although it's using the same software, Android software. There you go. There you go. There you go. Control V. But I'm going to display B here. Yeah, I did it on a Chromebook on question 52, so let's see how this works. A little tablet with a Bluetooth keyboard. Hopefully that should be good. And this is delta t. So what do we say delta t would be? Pi over 2, right? Pi minus 0 is pi over 2. Yeah, pi over 2. So this is going to be delta. This is just a label, guys. This is what gets evaluated. All right, see that that setup is correct. And by the way, if you had the script from question 52, all you had to change was your a, b, and n, and your x of t and y of t, and everything else would have been recalculated automatically for you. Which is nice about Pythonic scripts like this. Okay. All right, we're using Python. All right, so what are we going to do? Let's create a line. Let's create 2 lines. Okay. So I'm going to create, where am I? I'm going to create line 1. I'm going to call it L1 equals a line. Okay, now what you have to do is give it a list of 2 points, 2 endpoints. All right, so how about we start at x of a, comma, y of a. And then we'll stop at the other endpoint will be x of a plus delta t. So in other words, halfway, right? So x of a plus delta t, comma, y of a plus delta t. All right, and then just for fun, what am I going to do? I'm going to color this red, just so it stands out. Now, the default color for graphing here is sort of blue, so I'll let the function be graphed in blue, or in this case, not the parameterized trajectory, which may not be a function. And then the line segments will be red. Okay, and then I'm going to store this as a plot. Plot of line 1 equals the plot of, well, line 1. Ta-da! And we're going to superimpose or concatenate all our plots together in a minute. All right, so now line 2 is going to be similar. Why doesn't it? There you go. So line 2 is going to be similar. Alrighty. Except we're going to call it line 2. Now this one starts at the second endpoint of line 1. So plus a plus delta t and a plus delta t here. And this will be a plus 2 delta t's, but isn't that just b? So I'm just going to write b, because you get all the way to b now. Alright, so we want to graph this with the parameterized function, or relation between x and y. Alrighty, and so let's do that. The plot of xy is going to be parametric plot. There's a parametric plot 3D. This defaults to 2D. All right, what we're going to do is we're going to graph all the points x of t, y of t. Okay. Well, I don't think, actually, I don't need those parentheses. X of t, y of t. And for t varying from, on the domain, t goes from a to b. All right, good. And that's already a plot, so I'm going to show the plots. There we go. So show pxy concatenated with pl1 concatenated with pl2, the 3 plots, and let's do a blank show here. Alright, let's see what we messed up. Alright, so hopefully we got the graph. Nope, what did I mess up? What did I do? I did something weird. Oh, I didn't change the name here. Okay, so this here, this is going to be PL2 based on line 2. Okay, is that the only thing I forgot? That's what happens when you cut and paste too much. And boom, so the blue curve is the parameterized trajectory, which clearly is not a function. Well, actually, no, it's not a function. It doesn't pass the vertical line test everywhere, so it's not a function. If t goes from 0 to bigger than pi, maybe it's some kind of spiral, I don't know, whatever it is. And look at the red line segments are really underestimating that length. So let's see what that length is, and let's compare it to the arc length formula and see how close we get. Okay, so I think I got a length of 28.549-ish, but it should be 31.312-ish, I think, if I look at my notes correctly. Alright, so part B is doing the distance formula. Alright, so let's create a function. Oops. Alright, let's define a function called dist, short for distance formula. And it takes in 4 parameters. x1, y1, one end point of the line segment, or trying to find the length of a line segment, and x2, y2, the other point in the line segment. Okay, good. And what we're going to do is we're going to return. Be careful when you're on here. The colon automatically gives you 4 spaces as an indent. That's syntactic. Don't play with the indents, especially if there's more than one line here. That's going to mess you up. Okay, so what I want to do is I want to do the distance formula. So the square root of square it, not use this keyboard, add it, and squirt it. And what are we squaring? delta x, which is x2 minus x1, and we're squaring it so it doesn't matter the order really. You could do x1 minus x2 if you want. Same thing with y2 minus y1, and it's just finding the hypotenuse of the right triangle created by drawing a right triangle with that line segment being a hypotenuse in your graph, right? So, alright, so let's find that d1 is going to be the distance formula applied to x at A, y at A, then x at A plus delta t, y at A plus delta t. So it's all based on A, B, and N, and x of t and y of t. So if you already have this code from question 52, just change those lines and reevaluate, and everything's done. Alrighty, and so let's close the distance function. Okay, and let's show that amount. Okay, so what is it? d1 equals, that's a label, d1. Alright, let's see what we get here, just for that much. The square root of e to the pi plus 1, huh? Yeah, I think I need this as a decimal. So let's convert it to a decimal, just to see how the values converge eventually. So dot n gives me a numerical approximation. Remember, the computer algebra system loves to give you, whenever possible, exact answers in simplest radical fractional factored form. But that's not what I wanted here. 4.913-ish is about right. Okay, good. I'm just checking my notes. I did this already. Alright, so now D2 is very similar. Come on, let me copy this. Come on. Let's copy. Why doesn't this want to copy? There you go. Sort of a pain on my Droid tablet. It's easier on the Chromebook. Alright, so I'm going to copy this. Let's put it here. Control V it. And let's not make the same mistake we did before. That's a 2. That's a 2. That's a 2. Okay. And this starts at x of a plus delta t and y of a plus delta t. Come on, copy. Why is this copying? I just want to copy this line. Hello. There you go. Alright, so now I'm going to copy, not the line, I want to copy this input. Okay, so these two values, I want to copy this and put it here. But actually, I don't have to do that. I have to go up to b, right? I was going to put 2 times delta t, but okay, b and b. Don't be ridiculous. And let's see what we get now. For D2, previously I got 23.6 something. Yep, this is working. Alright, so I want the sum to estimate the arc length, which is really going to be an underestimate because the shortest distance between 2 points is the line segment joining them, and this curve is going to be longer than that, right? So let's show. Right, so let's show the sum. So show the sum, D1 plus D2 is, well, D1 plus D2. Okay, let's see what we get now. And so this was an underestimate I got last time I did this, 28.549-ish. And now I have, oh, well, I have to make that a numerical estimate. Well, that's the exact value, right? Okay, so let's make a numerical estimate. That's what I want. So let's put this in parentheses. Dot end function. Some people call that enifying. That's not English. Don't tell your English teacher. And 28.549-ish, right? And that's an underestimate. So we're going to see in 1 minute. Part C. In part C, we're going to do the arc length formula using the integral to get a more exact answer. So let's separate our output. And here. Okay. So what do we need? We need x prime of t. Okay, it's going to be differentiating x of t with respect to t. Whoops. Alrighty. And just for fun, let's see what that is. This keyboard is sort of little. And so product rule and so forth and so on of e to the t times cosine t should give you something like negative e to the t sine t plus cosine e to the t cosine t, something like that. Let's see if that's what we're getting. And yep, that's it, right? Doing the product rule there on e to the t times cosine. All right, let's do the same thing for y prime. So can I just copy this? Yeah. All right, it's very similar, just y instead of x. So I'm going to copy this and put it here. Control V it. This is a lot smoother on a Chromebook, huh? Oh well. All right, this is y prime, y of t, y prime, and evaluate. And that's going to be e to the t sine t plus e to the t cosine t, something like that, right? Let's see. Yep, there it is. Okay, so now what's the arc length formula? Well, the arc length formula says this. All right, we're going to say, all right, let's show, whoops, type fast and you type slow. Okay, the length L is equal to, okay, so what is it equal to? It's going to be the integral, sort of like of the distance formula, right, of the square root. Okay, so it's going to be the integral of the square root of x prime of t squared plus y prime of t squared evaluated with respect integrated with respect to t. Let's see, wait, hang on. Let me get out. Right, with respect to t from a to b. Okay, let's see what we got. And it's clearly going to be more than 28.5 whatever. Oh, again, I want to make a numerical estimate of that. Alrighty, so let's, and by the way, when you there's a lot of trig identities here you could use to simplify this and do this by hand, I'm sure, because cosine squared plus sine squared equals 1. So if you square these guys and add them up, I'm sure you could probably get something that's easy to integrate if you factor out the cosine squared plus sine squared stuff. But it's set to use a computer algebra system, so let's do that. Okay, so here I'm going to put numerical estimate. Let's see if we can get some convergence when we get to n equals 4 line segments and n equals 8 line segments. And so 28.549 is an underestimate 4, 31.312-ish if you're running off to the nearest thousandth, which I usually do. Okay, good. That's great. Now, let's make this more line segments. Yay! Okay, so I'm going to make this 4 line segments. So I'm going to copy. Stop it. I'm going to copy these 2 lines. Put them here. Make it line 3 and line 4. Plot of line 3. Plot of line 4. So this is, they ask you to do this for n equals 2, then n equals 4, then n equals 8, right? So here's n equals 4. Let's change this to n equals 4, just to be complete. And this is going to be n equals 4 in a minute also. Alright, so what are we going to do? We're going to change this to, so notice line 2 is wrong. It doesn't stop at x of b, y of b, because we have to go halfway, right? So what we're going to do is we're going to change n to 4 here. It's the main thing. And so delta x is a quarter, pi over 4, right? It's a quarter of a pi. Alright, so what if we copy this, x of t, y, this thing, copy it, put it here, but now say a plus 2 delta t's. There you go. And so same thing happens here. This one starts at a plus 2 delta t for x, or sorry, for t. But since this is line 3, it ends at x of a plus 3 times delta t. And we probably should have made a for loop to do this more elegantly, as it were. And so this will be at 3 times delta t away from a for the t value, and that is x of b and y of b, which is a plus 4 delta t's, right? So I think, did we update everything? Line 1, line 2, line 3, line 4, I think we did. Alright, let's see what the plot looks like. We don't have to change the parametric plot, that's the same. So now n is 4 and delta t is pi over 4, and what happened? Oh, I didn't show them all. Okay. Yeah, I have to show now these two new plots. Plot of line 3 and plot of line 4. There you go. So you should see 4 line segments of equal length trying to get closer to the arc length, which is blue. And it is a little bit closer. It's still going to be an underestimate, though. Alright, let's see how bad this underestimate is. Alright, so let's go to part B. We're doing the distance formula. Alright, so let's copy this. Where is this? No, paste nothing. Get over here. I want to copy something. Why does the copy thing go away? There it goes. I'm going to copy these two lines, just as I did with L1, L2. Okay? And I'm going to make 2 more distance formulas calculations. So copy, place it, Control V to paste it. Okay, so this is going to be D3 for the length of line 3, and D4, same thing here. Alright, fun with coding in Python. And this is 3, and this is 4. Alright, we're going to do the same thing we did before. And copy this. Now it's not a point, it's just an x value and a y value, so no extra parentheses there. Copy that, put it in place of this. So instead of going up to t equals b, we got to go up to t equals a plus 2 delta t's, right? Just like we did before with the lines. So put 2 times here, put a 2 times here. Same thing there. We're getting good at this, huh? And then this is line 3, so it ends at 3 delta t's. See the pattern? So we could probably take advantage of that pattern, or exploit that pattern, and write a little loop, which is a lot less code, but let's not get that crazy. And then a plus 4 delta t is b. There you go. Alright, so now let's add d1, d2, d3, and d4, and see what we get as our better estimate. Now remember what it was. It was 28.386. It should be more than that, but less than the 31.312, right? Okay, so that's what it is. Hit evaluate. And we got 30, it's getting really close, 30.537. It's supposed to be 31.312, but we only are using 4 line segments, right? Okay, how much better can we get? So this is the idea of the whole question. What's happens as n gets bigger and bigger and bigger? In fact, if n goes to infinity, you're going to get closer and closer to the right answer, is what it is. All right, let's do this for n equals 8. So I'm going to put this as 8 and 8. All right, good. So change this to 8. There you go. All right, so let's get 4 line segments. So we do like before. Copy this. Copy these 4 lines of code and place it here. And then rename this as line 5. All right, just like this, just like before, but now it's 8 lines. So line 5, line 6, whoops, line 7, line 8. Same thing here. Plot line 5 based on line segment 5, and then plot line 6 based on plotting line 6. This is getting a little long, and this is going to be 7, and this is going to be 8. Alright, and before we forget, we're going to plot the parametric plot of xy and plot of line 1, plot of line 2, plot of line 3, plot of line 4, and plot of line 5, concatenate that with plot of line 6 plus the plot of line 7, and concat finally plot of line 8. So you should have 8 equally long, the same the same length, 8 line segments of equal length. There you go. All right, now what we want to do is we're going to copy this, and this is a point, so I need that parentheses there. Get rid of this, because it's not b, it's half of b at this point on line 4, which is 4 delta t's, right? So I'm going to put a 4 delta t here. Same thing here. Delete that, Control V that, and make this 4 to start, and 5 to stop, because it's P5, L5. 5 times delta t, 5 times delta t. Okay, and this one starts at 5 times delta t, because it's line 6. And stops at 6 times. Very easy to modify this. Very nice. So this computer algebra system is the best of both worlds. It's sort of like Mathematica and sort of like MATLAB, but it's different from, say, Wolfram Alpha. If you know Wolfram Alpha, which uses Mathematica, because you don't code anything there. You just input stuff, and it guesses what kind of questions you want, right? So this is better in that you can code the output that you want. You have a lot more control, I think, and then you're understanding better what you're doing. And so this is line 8, so it starts at 7 delta t's. And it ends at 8 plus 8 delta t's, but that's b, so I think we got it. Let's try it. Hit evaluate. And there you go, look, 8 line segments. Well, they're not of equal length, but they're equal delta t's, right? Some are getting longer and longer and longer, right? So I shouldn't have said of equal length. Okay, and so what are those lengths? Let's see what our underestimate is now. It's going to be better than what we had so far, which was what? 27 point... Wait, hang on. For part B... Grand equals 4, right? It was 30 point something. What happened? Oh, okay, it's recalculating because I changed n equal to 8 now. Alright, so that's not even there anymore. That output is not what we had before. Okay, so that's correct. Alright, so we did the 8 lines. Now let's do the 8 distance formula. So let's do the same as before. Copy this. These 4 lines we had already. It's very similar for the last 4 lines. Copy. Enter to place. Control V to paste. Alright, and so this is going to be D5, D6, D7, D8. Okay. And this is going to be D5, D6, good, nice, D7, and D8. Alright, very good. And we've got to change the endpoints. Alright, the x1, y1, x2, y2, right? So let's see, this is 8. And so don't forget to display the sum of all of that stuff. So plus D5 plus D6 plus D7 plus D8. Alright, same thing here. That, because that was just a label, here's the calculation. D5, add up 1, 2, 3, 4, 5, and 6, and 7, and 8. Alright, so let's change up the code. Here we go. Let's do the same thing as we did before. I'm going to copy this. And it's not a point, so I don't need those extra parentheses. It's just two values of x and y. Okay, so copy that. Replace this, because it's not up to b anymore. It's half of b, which is 4 delta t. Whoa. Whoops, sorry, I don't know what happened there. So now it's 4 delta t's. Okay. And the same thing here. It starts at 4 delta t. A plus 4 delta t. And stops, since it's the length of line 5, it stops at 5 times a plus 5 times delta t. Just like we did above with the line segments in part B, I guess, or part A, sorry. This is part B. Okay, so this needs a 5. And it's line 6, this has to be 6. This ends at 6, so this starts at 6. And this ends at 7. Yeah, that would be crazy 37. And this starts at 7. A plus 7 delta t's. Don't mind my dog. Working from home in the pandemic. It's fun. And then B is A plus 8 delta t, so I don't have to write that. And I think we're complete. So let's run that. Alright, so what do we got here? We've got a sum of 31.112, which is really, really close to what it should be, 31.3112, but it's still an underestimate, so there you go. Alright, so there's your output for part C. That didn't change for n equal 2 and n equal 4 and n equals 8. There's your output for part B for n equals 8. There's your output for part A for n equals 8 again. There you go. There's your input. There's your code for part C. And here's your code for part B for n equals 8. Here's your code for part A for n equals 8. Here's your input, and that's it. Okay, I hope that was helpful, numerator. Good luck with your homework. See you next time. Bye-bye.